Prashant Wakhare, Department of Information Technology, AISSMS, IOIT Pune. So today I will going to discuss the concept of the permutation. So this concept is introduced in computer engineering as well as information technology department in the engineering background. So first we'll see what is the permutation and how we can solve the real-time example through the permutation concept. So permutations means it is an arrangement in a sequence of elements of a set, and that is called a permutation of elements. So in this slide I have written the definition of the permutation is an arrangement of n different objects with consideration given to the order of the object. That means depending upon the nature of arrangements, there are the three types of the permutations. So basically first type is the permutation when all objects are distinct. Then permutation when all objects are not distinct. And last one is the permutations with repeated objects. So these are the three types of the permutation. To find the number of permutation of the n items, we can use the fundamental counting principle or the factorial notation. So I think we all know which are the fundamental basic counting principles. That is, the first counting principle is the sum rule. Sum rule, it is also called as the principle of the disjunctive counting. And next one is the product rule. And product rule, it is also called as the principle of the sequential counting. So these are the fundamental counting principle or the factorial notation. So we'll see what is the permutation. The number of ways to arrange the letters A, B, C, capital A, B, C. So in this example, first what we'll do, we'll select number of choices for first blank, that is the number of. So first we'll select the 3. Then choices for the second blank, we'll select the 2. And choices for the third blank, we'll select the 1. So question is the number of ways to arrange the letters A, B, C. That is the factorial means 3 multiplied by 2 multiplied by 1, that is the 6. So 3 factorial means 3 multiplied by 2 multiplied by 1 equal to 6. So total number of ways to arrange the letters, we can arrange these letters ABC, we can arrange the ACB, BAC, BCA, CAB and CBA. So total number of ways to arrange the letters ABC, it is the 6. I think all of you understand this permutation concept. We'll see the next one, how we can solve the real-time examples in the permutation. So see, this is the formula. In general, the permutation of n object is taken n at a time is, the formula is the n permutation n. So your n is the total number of n, and after the permutation this n is the how many you are selecting, how many objects you are taken So these are the n. So that is the formula is the n factorial divided by the n minus n factorial. So n minus n factorial, it will be the 0. So that is the 0 factorial means 1. So n permutation n final is the n factorial. So thus n factorial is the n factorial multiplication n minus 1, n minus 2, n minus 3 up to 1. So if you understand this formula, then we can easily solve the real-time examples of the permutation concept. So see the first example, in how many ways can a boy arrange his 5 different toys in a row? So total n is that they have given the 5 and they are asking in how many ways can a boy arrange his 5 different toys. So it the R also means the after the permutation n it is also the 5. So 5 factorial. So if you calculate this 5 factorial, that is the 5 like 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1. So it will be the 120. So see examples you will more clear. So in this example, how many different ways can 12 skiers in the Olympic finals finish the competition if there are the no ties? The condition is the if there are the no ties. So your total number of n is the 12 permutation and we are selecting here, we are taken the 12 element also. So this formula is the 12 factorial. So 12 factorial means 12 multiplied by 11 multiplied by 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. If you solve this example, you will get this 479001600 different ways.